Guys, I guess welcome back to review videos. So I'm gonna go through this. This is not every single thing on the test, but this will really give you a good idea of what you want to focus on and what you want to study. Okay, so the first question says to rewrite using a fraction for an exponent. So basically anytime we have this little number in here, that's called an index and that's a root. So I would write that as the fraction 1/4. So I would write this as 243 raised to the 1/4 power. Okay, so anything that's inside there is considered a root. So like another example would be, say I had a little tiny 3 in here, and here I had an x squared. That would be the same as x squared over a 3, so because that little root is a 1/3. Okay, so using that idea, I can simplify this. So the 16 would go underneath the radical, and that numerator means that the 16 is being raised to the 3rd power, and that denominator means it's the 4th root. Okay, and you can actually put that stuff straight into a calculator to see. So I can actually type it, and you can type it with the exponent or with the radical. So I could actually type it as 16 raised to the power, if I could remember from 2 seconds ago, 3/4. And you can simplify it that way. It becomes 8. Okay, so why did it become 8? Because if you think about 16, the 4th root of that would be equal to 2, because 2 times 2 times 2 times 2, 4 2's, 2 times 2 times 2 gives you 16. So the 4th root of 16 is 2. And then remember that 2 is being raised to the 3rd power, so that's 2 times 2 times 2, which gives you the 8. Your calculator is really helpful on anything that is just numbers, obviously just numbers. Okay, to rationalize a denominator, we're going to use the conjugate. So this actually goes back to difference of 2 squares. So I would write 3 subtraction radical 2, because I want this idea of a plus b times a minus b, the difference of 2 squares. Okay, I write that as the conjugate over the conjugate because I'm making a fraction equal to 1. Whenever you have the same thing over the same thing, that value is 1. So if I multiply anything by a 1, I might change the look, but I won't change the value. All right, so that's multiplication. This is going to be the distributive property, which gives me 12 subtraction 4 radical 2 over. And now I'm using this difference of 2 squares idea. So remember, it's equal to a squared minus b squared. So the a is a 3, so a squared is 9. And the b is a radical 2. Radical 2 squared is the whole number 2. So that ends up being 9 minus 2, which is 7, which is a rational number. And that's why you're rationalizing the denominator. Now the denominator is a rational number. I'm just going to copy that. Sometimes it simplifies even further, but 7 and 12 don't have any common factors. You can also type this into the calculator, and it's going to give you this like ugly decimal. And then you can type your answer into the calculator and just make sure you get the same ugly decimal. Okay, factoring completely. I'm gonna always start with a GCF. So like my greatest gift is GCF. I am always gonna start with that. If you don't start with it, you're not wrong. I think you're just making your life harder. So I would always start with a GCF, okay? That would be my advice to you. So I look at the 3, I look at the 75, and I know that there's 3/4 and 75 cents. So I'm gonna divide by 3. And now I notice that that's the difference of 2 squares. So I do x adding 5, x subtracting 5. Okay, so a lot of times we're looking for patterns. I like to look for the difference of two squares, the sum or difference of two cubes. I also like to look for my perfect square trinomials because I totally love them in life. So, you know, you want to look for patterns. But again, GCF first. So I divide everything by 2. And I do this 1 times the 10, which really doesn't do anything, but I'm doing it just because. So I'm looking for factors of 10 that will give me a difference of 3. So I'm choosing the 2 and the 5. And again, there's more than one way to do this. I'm doing it by, I call it splitting the linear term. I think some of you were calling it eyeglasses. You can call it what you want. Just make sure you know how to do it. Okay, so, oops. Oh, I hate this computer sometimes. Oh, that went really far. So now I'm looking for what's common between the first two. And what's common is an x. And I always go with, hey, I'm right, that x minus 5 is going to repeat. And then I'm looking at the last 2, and that's a plus 2. So I didn't lose that 2 in front. That's going to be part of the answer. So my final answer is 2 parentheses, x subtraction 5, and x add 2. I get the x add 2 from this x and this plus 2. Okay? Anything that has just a single letter, like this 3x squared minus 75, if you type this in the calculator and you type this in the calculator, you can just check that they're equivalent. That's one way to check, just using your graphing calculator. So the same thing here, if I type this into my y sub 1 and I type this into my y sub 2, I just want to make sure that they're equal. Factoring doesn't change like the value of something, it just changes the look. All right, so GCF is x. And then I notice that these are the difference of two squares. And again, you can check it in your calculator. Oh boy. So if you see 4 terms, I would say try to think of it as groups of 2. So here what's common is an x squared. And that gives me x plus 4. I always assume I'm right. And that gives me a minus 9. So I have x squared minus 9 and x plus 4. Now that's factored, but if you notice this is the difference of 2 squares right here, so that gets factored again. So it's sort of like factor till you can't factor no more. And again, I would look for patterns. So I look at this, I separate it into 2 thoughts, and I say what's common. And then I always assume I'm right, so this part here has to match this part here, otherwise there's some kind of mistake. Okay? All right, letter E. I'm kind of feeling this green right here. Okay, 9's a perfect square, x squared's a perfect square, y to the 4th's a perfect square, 16's a perfect square, z to the 6 is a perfect square. Remember, anything with an even exponent is a perfect square. So even exponent, perfect square. So this is the difference of 2 squares. Okay? So think of this as the A, and think of this as the B. So I take the square root of 9, I take the square root of x squared, I take the square root of y to the 4th. Okay. One's a plus, one's a minus, and you can switch whichever one out you want. The square root of 16 is the whole number 4, and the square root of z to the 6th is z to the 3rd. You do have to check to make sure there's nothing common, and then you know you're done. So that was the difference of 2 squares. Oh, right. I want to go pink. this is the difference of two cubes. Okay? I don't even know if that's an acronym, so I'm going to erase that because I just feel kind of weird, but it's the difference of two cubes. Okay. So that is where you have to take the cube root of stuff. So I'm still on an eraser. How do I get out of the eraser? I guess this is it drawn. Okay, back to pink. All right, so I take the cube root. That 3 is inside there. I know I didn't draw it very well. And that's x. I take the cube root, and that's 3. And you can always use your calculator. If you don't know your perfect cubes, one thing is if you go to y equals and you type in x cubed, and then go to your table, not the graph, but the graph is kind of cool. It'll give you your list of perfect cubes. Okay, just like a list of perfect squares from x squared. Okay, so this is that SOFAS thing. So a subtraction b, and remember this is the s for the same, and then this is a squared, this is ab, and this is b squared. So it's same, opposite. Always, oh, I said sofa, but it's soap. My goodness me. Always positive, soap. So get clean with your math, okay? Use some soap. All right, so x minus 3, because a is x, b is 3. X squared, because it's a squared, plus a times b, so 3 times x, and b squared, so, sorry, plus 9. Okay? You do have to memorize that formula and use a little soap. I like that. Okay, so a plus 2b's. So a is negative 3 plus 2i plus 2 times the quantity, 4 subtraction 6i. So negative 3 plus 2i plus 8, because that's the distributive property, subtraction 12i. So I'm going to put my numbers that are integers together, so I get 5. And I'm going to put my i's together, and I get negative 10i. So when I'm asking you to sketch, I'm basically asking you what quadrant is that in. So it's a positive and a negative, so that would be down here, and that's quadrant 4. Okay? All right. Find the sum. Truthfully, anything that is multiple choice you can do on the calculator. It's kind of a cheap way of doing it, but it's a great way of checking it. I could also have typed in all of this into the calculator and gotten this answer, so it's a great way of checking it. I would stay away from the calculator doing my work. I would try to do my work and use the calculator to check it. That's my advice. Okay. All right, so I've got to break down this negative 49. So I think of this as negative 1, the imaginary part, and 49, the perfect square. So that gives me 7i. I got to break down, sum means to add. I got to break down this negative 81 square root. So I think of that as the negative 1, the imaginary part, and the 81, the perfect square. So that's minus 9i. It's only minus because that was a subtraction sign right there. Okay. I add negative 6 and 2, I get negative 4. I add positive 7 and negative 9, I get negative 2. And here's the answer. Again, the calculator can do that. I would still try to do it. Okay. This video might be longer than the usual Algebra 1 ones because this stuff is harder, but it's fun. Okay, so when you square something, it means to multiply it by itself. So again, my advice would be just write it out because it'll help you. So 3x times 3x, this is the distributive property. 3x times negative 2i is negative 6 6xi, and you can write that as 6ix. I would just look at what the multiple choice looks like to see like how the test writer writes it. Okay, and then this is negative 6x. Oh, because it's going to be a perfect square trinomial. Yeah. Oh, look at that fun. Negative 6i. And then this is going to be plus 4i squared. Now, if this was Algebra 1, we would stop, combine like terms, etc. But Algebra 2, you have to remember that you have to replace the I squared with a negative 1. Okay? So you got to do that. So this becomes a negative 4. All right? So the 9x squared, combine the like terms, negative 12xi minus 4 for the final answer. I'm not quite sure, but I'm pretty sure the calculator would check it because it has just the x in it. So I'm quite certain the calculator will check it for you. Here we go. All right. Difference of two squares identity. So that's what I was talking about before, where you have a minus b times a plus b equals a squared minus b squared. So I'm going to make the letter A blue. This right here is the letter A. Okay? This right here is the letter B. You see it? A squared minus B squared. So what they're saying is, does that equal a negative 8x? So I'm actually going to write it by saying A is the same as x subtraction 2. Maybe I should have written that in blue to help you. A is the same as x subtraction 2. Now I made it worse. A is the same as x subtraction 2. B is the same as x add 2. And I'm just getting that by recognizing that this is the A and this is the B. Okay, so now I'm going to go back to this A minus B. So x minus 2 minus x plus 2 times x minus 2 plus x plus 2. Okay, I'm using this up here. Scroll down a little so you can see it. Okay, A subtraction B, A add B. All right, now I'm going to do this math. Whoops, now I'm going to lose the paper. Thank you for your patience with me. Okay, so x minus x would be 0. Negative 2 minus 2 would be negative 4. Okay, x plus x would be 2 x's. X plus x is 2x. And negative 2 plus 2 is 0. So remember that means times. So this is negative 8x. Did it work? Let me scroll. I gotta move my face and just zoom in and see. Did it work? Did it work? Negative 8x. Did I get negative? Yes, it worked. So you would say negative 8x equals negative 8x. It is true. All right, so that's what I made for you. I really, really, really wish you good luck on your test. I do have extra help after school. Not going to help you because your test is Tuesday and there's no extra help on Mondays. But let me know what you need. And I hope you enjoyed the video. Have a great day.